was gonna be this way.
Welcome to Cooking Chemistry.
Today, we will be cooking a cake.
And learning science.
We're going to be talking about one of the factors that determines the rate at which a reaction occurs. This one is temperature. The temperature at which the oven is set is obviously going to affect the rate at which the reaction will occur.
The setting determines how much energy is being put into the reaction.
For example, if a higher temperature is being used, it's going to be putting more energy into the reaction, which is going to lessen the time, because more energy is being put in the molecules, which means they're going to collide faster and more often, and the reaction will thus be shorter.
Yet, if a low temperature is used, less energy is going to be put into the reaction, and it will take more time because the molecules will be moving slower.
For our cake, the oven will be set on the higher side. Thus, more energy will be put into the reaction, causing the molecules to move faster.
And that is why it does not take an excessive amount of time for the reaction to occur.
However, it is not an extremely high temperature, so the reaction will not occur at a super high speed.
So here are all of our ingredients, and we're going to be putting it in the spot. But while we do that, let's talk about conservation of energy.
This law declares that in any given chemical reaction, energy can never be created, lost, or destroyed, and the amount of energy in the reaction will remain constant.
In terms of baking, any energy given off by the oven or whatever is being used to cook, the reactants will never be lost or destroyed, and the exact same amount of energy will be given to the reactants.
The intensity of the setting on the oven will affect how much energy is put into the cake, as well as the condition and time of the reaction.
After the cake is removed from the oven, the same amount of energy/heat will be expelled through cooling.
Eeny,
Meeny,
miny,
mo.
Specific heat is the amount of energy required to heat up a substance by 1 degree Celsius.
The heat of a product determines how much energy the oven needs to give up, so it only takes a reasonable amount of time to bake.
The apples in the cake have an approximate specific heat capacity of 3.64 joules per grams degree Celsius.
This means that compared to water with a specific heat of 1.00 joules per gram degree Celsius, it takes a time for an apple to heat up or to cool down.
Ah! Watch out! Don't eat it right away! It's still hot!
Hey, mijo.
Huh?
Yee!
Prior to putting the mixture into the oven, it is in a liquid state.
After baking, it is a solid. This is because it goes through an endothermic reaction, different to the conventional process that involves pure substances.
A single type of element or compound with a uniform chemical makeup.
And as energy is added, it becomes a solid.
Correct, mijo.
Let's talk about surface area. The larger the surface area is compared to its volume, the shorter time it takes for the cake to cook.
This is because it gives more opportunity for interaction with the heat to reach the inside of the cake. Since this is not an excessively large cake, the reaction time will not be incredibly long, especially since there is a large surface area compared to the actual size of the cake.
This allows more heat to reach the center of the cake. It is an endothermic reaction. This means that the energy is being put into the reactants, and the products end up with more energy than the reactants.
Typically, when a substance goes from a liquid to a solid, such as a cake baking, it is classified as an exothermic reaction.
However, since this cake batter is a heterogeneous mixture, the conditions are changed.
So, although it remains an endothermic reaction,
The reactants go from a liquid to a solid as a product.
No, bro, it's not in Spanish. You're a bot.
Our product is a state-of-the-art heating pad.
That's right. But how does this relate to chemistry?
Oh, I know. It's...
The specific heat of the pad.
I was gonna say that.
Not only does our product help your aches and pains, but it does so quickly.
Well, how is that possible?
It's because it has an incredibly low specific heat capacity. That means it requires a very low amount of energy to heat up.
Oh, I see. It only requires a very small amount of joules to heat up.
This means it heats up quickly, as well to lessen the amount of time spent in agony.
We hope you like our product.
Ciao.
Adios.
Nice one.
This is our cake.
We hope you learned how to make it with science.
And had some fun too.